Hello, Honors Chemistry, and welcome to Chapter 1, the Introduction to Chemistry. Chapter 1 is not much of a chapter, so do not let this be indicative to you, right, about what chapters in chemistry look like, but we have to start somewhere, right? Definitions. Those are key things that we should obviously know, right? Chemistry is the science that tries to understand how matter behaves by studying how atoms and molecules behave. So, chemistry is about matter. Matter is atoms, right? And so really when we're talking about chemistry and chemicals, right, which would be the things that chemistry studies, right, it comes down to everything made of atoms and how those atoms behave. Now, if we're thinking about things on Earth, right, or just things in general, right, name something not made of atoms. You should struggle there, right? If you think back to your middle school science classes, you should be able to come up with a couple of things. Like, for example, light, perhaps, right? Sound, energy, right? Those would be some examples of things that are not matter, right? Because the fact is that everything is made of atoms, right? You may not exactly know what the atomic makeup of something is, right? But it's made of atoms, right? At its basic level, right? And so this picture from your guys' book tries to illustrate that, right? Where we have, our genetic material, right? We have the carbon that composes our lead, right? We have the water that makes up the solution and other chemicals that make up our beverages, right? Chemistry is everything, right? Now, when we're talking about chemistry, the labs that we'll do, which, hopefully by second semester we'll be talking about completely normal lab experience, right? For now, we're going to play it by ear and do what we can. But the point is that everything in chemistry, right, down the origins of the stuff that we're going to study, right, and the crux of all the labs that you guys will do, right, really comes down to observations. That's where everything starts. That's what everything is based on. Those observations support hypotheses or negate them, right? They support laws or negate them, right? And they allow us to revise what we think, right? And eventually, right, with enough observation, right, that repeats itself, right, we can come up with theories, right, that sort of explain those observations. But again, observation is very important. As we do more labs, or as we have the opportunity, we will sort of emphasize what your observations should and should not be like, right? Which harkens back to stuff that you guys already talked about in middle school, right? This stuff is not new yet. All right, there are a few EOCs listed in your guys' Chapter 1 section that I do want to talk about, right? Number 17, EOC number 17 says to formulate a tentative law, right? And this is our data, right? Where we have some mass of a gas and some volume of a gas, right? Now, most people will look at this and be like, yes, as mass increases, what happens to our volume? It increases also, right? Now, your book goes on, right, to talk about how creativity is necessary, right? Analysis, right? When they say creativity, really they mean the ability to thoughtfully analyze the data in front of you, right? So actually, if we analyze this a little bit more thoughtfully, what might we check? Right. We would actually go ahead and figure out what this ratio might be, right? If I take 22.5 over 1.6, what do I get? And then if I repeat that over and over again, it turns out that number is always 14 point something, right? Which means that not only does mass of our gas and volume of our gas are directly proportional, but they have a constant ratio for this particular gas of 14-ish, right? And that is a more creative and thoughtful analysis than just saying mass and volume are directly related, okay? Moving on to number 21, right? 21 says that the manufacturer of a particular brand of toothpaste claims that the brand contains no chemicals, right? And I'm sure that if you think about the advertising that you've seen over the course of your lifetime, you have also seen the exact same wording on something free of chemicals, blah, 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 right? Is that true? No, right? That cannot be true, right? It cannot be free of chemicals because chemicals are anything that's made of atoms, right? And so what is it that they are really trying to convey, right, to a general population when they say no chemicals in our product? Right. They are trying to convey that, our product is super safe. It's super natural. We didn't add any chemicals, but everything that we extract from nature is a chemical, right? Even when you eat your apple and you're like, this is so natural, right? But there are atoms that make up everything in your apple, right? And so it's ridiculous, right? So when we think about the word chemical, right, there should not be a connotation associated with the word chemical, right? Chemical just is something made of atoms, right? The types of chemicals that we use are different, right? And your book talks, shows some pictures of like, some, I think, paint thinner versus, I don't know, something else like water, right? So yeah, paint thinner is more harmful if you drink it than water, right? But it depends on what we're trying to do, right? If we're trying to take paint off of something, paint thinner is what we would want, not water, right? So anyway, just be mindful about that in terms of our word usage over the course of the year. So number 25 is just a data analysis question, right? Where can we read our graph, right? So anytime we have a graph, really, we should just take note of our axes, right? So here we have year, and it goes in increments of 50, right? Here we have our population, and it goes in increments of 1 billion, okay? First question, population in 1950. I assume we remember from math class, but we would go find 1950 on the x-axis. We would take this up, and then we would go over to our y-axis, and as best as we can, right, go ahead and come up with an estimate of like what, and here, right, we would use what we learned back in math class, right? We would take this 2 and this 3, and we would cut it in half, and then visually we might cut that in half again, and we would see that that is approximately 2.25 billion, right, is the world population in 1950, right? And then if it goes to the world population in 2010, right, we would again, here's 2000, here's 2050, right? There's about the halfway point, and that would put us at 2025, right? And so 2010 would be somewhere around the halfway mark there. Yes, just under the halfway. So then if we carry that up, right, and then we carry that over, right, same thing. That's going to be like 6.75 billion people, right? And if I want to do the increase between that, right, what are we going to do there? Right, that's just B minus A, right? For D, if I want to do the average rate of increase, what would I do? Right, increase over time means B minus A is going to give us a change in people, right? This is going to be people. And if I want to take that as a per time, I'm going to have to divide by my time unit, right? So that's going to be, 60 years. So I'm going to divide it by 60 years. And then I'm going to get a rate that gives us people per year. Yes, that is the rate of increase of people per year. And then if it remains constant, estimate the population in 2035. Well, from 2010 to 2035, that's a distance or a time lapse of what? Right, 25 years, right? And then if this gives us people per year, and then I would take that and multiply it by 25 years. Yes, does that make sense? All right. Last up, so the end of your chapter 1 section of your outline talks about the vocabulary of chemistry, which should be element names and symbols, right? So yeah, you do have to memorize these, right? We are going to use them all year, and there just needs to be a basic set of elements that you know, right? And so you have to know these and just the name and symbol. So when I say hydrogen, you need to know hydrogen is H, and it's spelled Hydrogen. That's it. You don't need to know that hydrogen is element number 1. You don't need to know that it has an atomic mass of 1.01, right? You just need to know H, hydrogen, right? And again, just name and symbol, right? So when I say He, you should say helium, right? When I say fluorine, you should say F, and make sure you know how to spell fluorine, right? And so name and spelling, and we'll have some quizzes on it in the very near future. All right. Thank you for listening. Be good, and I will see you soon. Bye.